So in this video, we're going to go over how to find the domain and range of a relation by looking at the graph of the relation. So we're going to look at relations that are associated with equations, but for which we've been drawn a picture of the equation so that we can analyze the graph of the equation to determine its domain and range. So remember, domain and range, if we're working with an equation that's generic, there we have x, y ordered pairs, and these correspond to input, output, or independent variable, dependent variable. And when we're doing the domain, we're always talking about the input or independent variable. So we're trying to determine or ascertain what values we're allowed to use for the inputs or independent variable. So in this case, if we're talking about domain, we need to figure out where x lives. So where does x live? So x is an element, and it's going to be an interval. And the convention is going to be for us that if we don't see an arrow on the ends of the graph, we're going to assume that there is an arrow there. Some of these graphs in the next few slides were created in GeoGebra, and GeoGebra does not put arrows on the ends of its graphs. So in general, we're going to have some of the graphs are going to have arrows. And those will be graphs that were made in other programs. GeoGebra won't have arrows, so you assume that there's an arrow there. If we want the relation to actually terminate at a spot, we'll put either a solid dot there or we'll put an open dot there. And if you see a solid or open dot, that means that the graph of the relation is terminating at that point. Without a dot, either closed or open, we assume that there's an arrow that says it's going forever. So what we want to think about is if there's an arrow pointing up to the left, what we want to think about is that that arrow can be broken into components. It has a leftwards component that points towards negative infinity on the real number line. So negative infinity is this way. And it has an upwards component that points towards positive infinity on the vertical axis number line. And what we want to remember is that the input variables are graphed versus the horizontal axis. So when we're talking domain, we're always asking where on the horizontal axis can x live. And this arrow right here is indicating that the x values are going off towards negative infinity. And down here, there's really an arrow at this end of the graph as well. So it has a horizontal component that points off to the right towards positive infinity, and it has a vertical component that's pointing down towards negative infinity on the vertical axis. So for the domain, what we would say here is that the x values can go from this arrow's pointing towards negative infinity all the way towards this arrow's pointing off towards infinity. In other words, x can be any real number. X is an element of the interval, the open interval from negative infinity to infinity. And for the range, we just have to identify what's going on in the y direction. What's going on with respect to this vertical axis. This vertical axis is the y-axis. So again, this arrow here has a vertical component pointing towards infinity. And down here on the bottom end, this arrow has a vertical component pointing on with respect to the y-axis towards negative infinity. So we see that y is an element also of the interval from negative infinity to infinity, or y can be any real number. For this example, again, the ordered pairs are going to be xy ordered pairs. And for the domain, we're just identifying where does x live. And here we have arrow going up to the right, and here we have an arrow going down to the right. And for the x values, what we see is that x actually has a starting point right here. So on the x-axis, this is the x-axis, this is the output or dependent variable axis, this is the input or independent variable axis, we can see the x values are actually starting at 0 and they're running off towards positive infinity because both of these arrows have horizontal components that point towards positive infinity. So in this case we would say x is an element. We're allowed to plug 0 into this relation. So x starts at 0 and runs to infinity, and it's open at infinity because x can never get to infinity. Infinity is a concept, it's not a number. You can't get there. You can try. So the range is just where are the y values running, and here we're talking now about the vertical axis. And when we look at this arrow, we see it has a vertical component pointing upwards towards infinity on the y-axis. And we see this arrow has a vertical component pointing downwards towards negative infinity on the y-axis. So the range has the y running from negative infinity to infinity. So this one here, we've got an arrow that has both a horizontal and vertical component, and here we have an arrow on our graph that has both a vertical and horizontal component. So for the x and y values, right, ordered pairs are x, y's. Our domain is talking about where do the x's live. X is an element of what interval, and here we see that the x's are running off towards negative infinity on the x-axis. And this arrow here, because of this horizontal component that's heading towards infinity along the x-axis, x is going to be an element of the interval from negative infinity to infinity. And for the range, we're going to get the same result. Y is going to be an element of the interval from negative infinity to infinity. And that's going to be because this arrow has a vertical component with respect to the y-axis that's heading towards infinity in the y direction. And this arrow right here has a vertical component pointing down towards negative infinity on the y-axis. For this one, if we talk about the domain first, that means we're talking about where does x live, where do the inputs live. So where on the x-axis do the inputs live? And this arrow right here has a component that's going towards negative infinity parallel to the input or x-axis. This arrow here has a component running towards infinity parallel to the x or input axis. So x values are going to run from negative infinity to infinity. And for the range, we're going to get a different result this time. Y is going to be an element. Now we're having to look at this relative to the y-axis. Here y is going towards infinity, negative infinity. And what we can see is there's a lowest point on this graph right here. 1, 2, 3, down at negative 3. So the lowest point on the graph is at negative 3. So the smallest output we can get is a negative 3. And both of these arrows indicate that we have vertical components parallel to the y-axis going towards positive infinity. For this example, for the domain, where do the x's run from? And what we can see is that we've got a closed circle here, so this point is included. We have a closed circle here, so this point is included. This graph is truncated because of the closed circle. So in the x direction, this graph only runs between negative 5 and 5 on the along the x-axis. So x is going to be an element of the closed interval from negative 5 to 5. That's where x gets to run. Had these been open circles instead of closed circles, then we would have said x is an element of the open interval from negative 5 to 5, indicating that the 5 and the negative 5 are boundaries beyond which x cannot be, but they're not included in the domain. But because of the solid dot there, the solid point, we're including those values. And then for the y's, for the range, we just need to know where's y running from. And when we look at this graph, we can see it has a high point at -1, and this graph has a low point down at -5. So the y values are running between -1 and 5. So again, the range is where does the picture live relative to the y-axis or the output axis. So this one has it runs on the interval from -5 to -1. So last example. So domain, where do the x's live? And what we can see is the furthest we get up as we move towards positive infinity on the x-axis, the furthest this graph gets is right here, over at 1, 2, 3. And then the graph is going infinitely far that direction because both of these arrows have horizontal components pointing towards negative infinity. So x is going to run from negative infinity all the way up to 3. 3 is included, so we use the square bracket there. And then the y values are actually going to run from, or the range, the y values are going to run from negative infinity to infinity in this case, because this arrow has a vertical component that's going towards positive infinity with respect to the y-axis, and this arrow here has a vertical component that's going towards negative infinity with respect to the y-axis.